to workshop very interesting and useful topic which is related with acoustics technology and we are facing in India. We have with us Dr. Naveen Garg, who is a principal scientist from National Physical Laboratory, New Delhi. He is basically working in the National Physical Laboratory since last 18 years. He has worked in acoustics and vibration. We have and I'm proud that he's an APMP Asia Pacific Meteorology Program awardee from this Asia Pacific science and all NMIs are the member of this APMP in the Asia Pacific region. He's an NABL assessor. We have with us Dr. Chitra Gautam, who is also a senior scientist in acoustics and vibration meteorology at National Physical Laboratory. She is specialized in instrumentation engineering and the PhD in the instrumentation. We have with us our Honorable Joint Secretary, Sir, Shri Vinay Mathur Sahab, who is with us to inaugurate this conference. Actually, sir, today we are having this program on this acoustics meteorology at the and this noise pollution, which is very important part playing in the lives of everybody. And sir, I have seen a system in Germany and in China also. They are having very good system laboratory in their country. I hope that at a National Physical Laboratory also we have the similar type of better kindly inaugurate this workshop which is linked with everybody's life. And as now as we are aware, we are regularly asking not to make noise. So kindly inaugurate, please, sir.
Yeah, thank you, Ashutosh Agarwalji, and good morning to all the participants. Good morning to Dr. Naveen Garg, Senior Principal Scientist and Head Acoustics and Vibration Metrology Department, IR, NPL, New Delhi. It is indeed a pleasure to be interacting with the listeners and as well as the scientific community who's working in the area of acoustic metrology. And as we all know, in the introduction, Ashutosh has set up that noise pollution is a major thing, which is largely, rampantly occurring across in the country as well as maybe across the world. There is a great demand that whatever are the instruments for amplification of sound and voice, they should be qualitatively and quantitatively looked into from the metrological perspective. They need to be calibrated according to the amplification and the requirements of metrology and the standards in this area. Now, every country sets up their own noise pollution control systems and standards, and India also follows a particular standard. But we largely see that there is a lot of instruments which are used, especially for amplification, where there is no measurement and no control, and a lot of people are to suffer because of that. There are certain things which the police can control, but largely our police force is also not very well trained into meteorological aspects and what exactly is the noise pollution level, mostly in smaller places, that is very difficult to measure. So on and all, there is a lot of problem of the noise. As we see with the volumes of traffic and vehicles growing on the streets also, there's a lot of honking and probably make use of the horns, which are at times beyond the limits of acoustic metrology and noise pollution control. So all these things are largely impacting the human life. They're impacting our hearing, and they are also impacting the overall pollution levels in air as well as in and around ourselves. So I think it is very pertinent that we possibly listen to an expert and what exactly are the developments in acoustics metrology and how noise pollution control probably should be looked into by the manufacturers as well as the users of various amplification items which are available. This also involves high, caliber and technique of physics, and I think we'll be listening to our expert, Dr. Naveen Garg, who has done a lot of work in this area, and he'll be able to guide us as to what exactly the consumers as well as the manufacturers should look into. This is certainly a huge area for business, and also there are a lot of manufacturers in this area. We can possibly export our caustic metrology items also across the world, but we need to possibly calibrate and be of the standard whatever is required in the various developed countries. So I think overall a very interesting area, and it will be a delight to listen to an expert who has worked for long in this area. And with these words, I thank Ashutosh and the legal metrology team and Department of Consumer Affairs who's been conducting these kind of seminars. Whatever points emerge out of this particular guidance and this seminar, we will certainly take forward from the policy angle. Thank you very much.
Thank you very much, sir. Thank you for your kind words. You are always motivating us for doing these type of activities, not for the legal methodology, for scientific. Certainly, sir, we are always obliged by you. Thank you very much, sir. Thank you. So,
Hello, Ashutosh.
we have Shri Bianti Daraji, sir. First.
So this is a very good and interesting program. Yes, yes. So this is very good and interesting program organized by RRSL Ahmedabad under the leadership of Sri Ashutosh Agrawal. And we are very obliged to Joint Secretary Sahib also, that he has spoken very nice things with the opening remark. And mostly the what he advised that this noise pollution and all these things should be controlled first at the manufacturer level, where the control systems are being made for that very things. So that says that the how much that their vibration level will be there, how much their sound level will be there, and how long it will continue, like that. For the vehicles and other things, the police are observing all these very things. Government has taken steps for the pollution of the vehicles and other things. But there are the many areas also where the environment pollutions are there, where the factories are there, and in rural areas are also there, where so many burnings of the uh, um, means the after the uh, crops has been cut down. So in Punjab we have seen the parali, and similarly the rest. This type of things is also done in the most part of the India also, sir. So the reason of the pollutions are a lot of things. One of the reason is the industries, where through these very seminars we can provide the signals that the manufacturer may bring the new technology, so that this type of pollution of noise, vibration, etc. may be controlled. Thank you, Astosi, and thank you, scientists from the National Physical Laboratory.
Thank you very much, sir. Thank you. Sir, we have with us Dr. Naveen Garg, who is the professor in the Faculty of Engineering Sciences of Academics of Scientific and Industrial Research at National Physical Laboratory. I would like to request Dr. Naveen Garg to kindly start your lecture so that we can be benefited, all the participants can be benefited from your knowledge sharing. Thank you, sir. Please.
Yeah, good morning, Ashutosh ji. Am I audible?
Yes, you are very well audible.
Yeah, good morning, everybody. And really, I'm very glad and thankful to Ashutosh Agarwal ji for organizing this beautiful seminar. In fact, this is the first opportunity that acoustics and noise pollution has come under the umbrella, or basically has been highlighted by the legal metrology department. And I think it's a very great initiative, and I really am very thankful to Ashutosh Agarwal ji. Also very thankful to Mr. Vineet Mathur, Joint Secretary. Sir, your words are very well taken. And yes, the words that you have mentioned, that really we are working on this phenomenon, on the various aspects of noise pollution control, about calibration of the instruments that are basically now being used for amplification of the loudspeakers, etc. As you know that now the noise limiters are being endorsed by the government of India to be a part of the loudspeaker systems. So CSIR NPL is really taking up this challenge with a private company, and we are planning to work on that, and maybe next 6 months or 1 year we'll come up with a technical solution for that. And really, I am thankful to BN Dikshit sir also for his presence during this event. And now I'll discuss about the various aspects as we discussed in the about acoustic metrology and noise pollution control in India. Friends, as you know, noise pollution has been a very serious issue apart from the air pollution. In fact, even if you are hearing the news, so today I think in most of the areas in Delhi city, the AQI level is very higher. But in fact, I am very sorry to say the media never highlights about the noise pollution. Maybe are we used to the noise pollution, or maybe it is a secondary pollution when compared to air pollution? I don't know, but really we have to take this noise pollution also as serious as air pollution. So I'll be discussing the various aspects of this particular thing in my slides, and I hope I'll be able to make justice with the objectives of the today program. So the contents of my presentation will be the introduction to the sensors and instrumentation and how the noise pollution is measured. What are the ambient noise standards of India? How far is the status of noise pollution in India and compared to the international scenario? Noise mapping, which is a recent tool that has come in India, but in fact it has been very widely used in Europe and American continent. The role of CSIR National Physical Laboratory in India in this regard, because CSIR NPL is working in this field, I think since past 3 decades, more than 3 decades, and really CSIR has NPL has provided a great support to all the pollution control boards of the body, to the various building manufacturers, to various other government bodies in controlling the noise pollution in the India. And I'll be definitely sharing about the acoustic metrology, how the acoustic standards are there, and what should be the policy development guidelines, where in fact the legal metrology can also play a vital role, so that noise pollution can be prevented and we can have a better metrology. We can strengthen our laboratories so that they are fully equipped for calibrating the instruments and preventing the noise pollution control. So let me start with the topic on concerns related to the traffic noise pollution. I think it is well known to everybody that the expanding vehicular population and overall human population, that is a serious issue, and this has raised a serious concern amongst the metropolitan cities. And you can see that in the vehicular population, the 6 top cities, Delhi, Chennai, Hyderabad, Pune, Mumbai, and Kolkata, these are the 6 cities that top in our in the country in terms of the vehicular population. If we go about calculating the years of life, the ill effects of noise pollution, so there has been a recent WHO report which is published by WHO, and in that it has quantified how the traffic noise accounts for the healthy life years of loss. So according to that report, the traffic noise is account to have around 1 million healthy years of life of lost annually due to ill health and due to the disease burden, and it magnitudes in second apart from the air pollution. So yeah, definitely air pollution is our first concern, but then noise pollution is also a serious concern, and I think in next 5 years it will be also a very major concern, because nowadays there have been many studies that have evidently they have correlated road traffic noise with the various health issues. Like some studies have mentioned that if the noise exposure level is more than 65 dBA, it can create an coronary heart diseases and other cardiovascular effects in the adult subjects. Road traffic noise affects the human work efficiency. I think that is very well known to everybody, and you might have experienced that when we are prone to the high honking noise levels or maybe the loudspeaker noise, sometimes we are really annoyed and we are not able to work at our homes or at office. So that is really a serious concern. Even some studies have reported that high noise levels, they affect our the learning capacities also. And most probably this feature is, this particular aspect is now being the researchers have analyzed for the students, because in the students who are basically, I hope you must have watched that the schools, particularly the schools, they are facing a very high noise pollution, because when in the morning and in the afternoon when the school is closing, so there is a huge rush in that roads nearby the schools, and a lot of honking and traffic noise is very high. So students are really affected by that, and studies have revealed that the learning capacity is also affected by the high noise levels. Apart from that, hypertension, abnormal disease, stress are the various documented effects that result in the myocardial infarction. So it is another sort of a cardiovascular disease where you are just due to the noise levels, you can see the various serious consequences. So we have to really work on this aspect. This was this slide shows that there was a survey actually in 2007. I cannot comment whether the survey was right or wrong. Just this was a, on this website it was mentioned that Delhi, if we compare the major cities of the world, so it was rating was that second noisiest city, followed by Cairo, Mumbai, Istanbul, and Beijing. So you, from this survey you can see that our two cities are listed in the top 5 cities among the top polluted, top noisiest cities. So we have to do a great job in this, and I think the government is really very serious. And in my subsequent slides, I will come about the seriousness of the government of India, the efforts they are putting on, and the role and efforts of CSR and NPL. So as I mentioned, that the burden of noise, the disease from environmental noise is really very serious. So you can see the photograph of this. This is the report that has been that has been published, and according to that, the health outcomes are evidently these are very evident now: cardiovascular diseases, cognitive impairment, sleep disturbance, tinnitus, and annoyance. So even the people who are exposed to the high noise levels, particularly the honking noise, so they are really annoyed, and sometimes they have a ringing effect in their ears. So that is called the tinnitus, which needs a medical intervention. And now it is evident that noise pollution is a major environmental and public health concern, second only to the air pollution. So I think if you go by the media news, so today I was just going through the news, and there was a concern about the air pollution, that AQI levels are very high. Then the second concern was that Yamuna River, the because due to the Chhat Puja, so there was a issue that yes, there was a fight actually, that the chemicals are there and people are not able to take a bath in that, or they are not able to do the puja. So I really wonder that maybe in next 2 or 3 years there will be also news on noise pollution, that yes, the noise pollution is also very serious and we are really affected by that. So I would request legal metrology department also to intervene in this regard. Apart from the Central Pollution Control Board of India, the Delhi Pollution Control Committee, the regional pollution control committees, I think the legal metrology department has also a big role in this particular area, where we can focus on strengthening our laboratories, so that they have a very good infrastructure for measuring the noise levels, for calibrating the instruments, and for developing new products which can be used for noise pollution control. So this is just basically a pathway, a physiological pathway, which shows, this is a German study where the researchers has shown that how the noise exposure level is basically affecting our body. And you can see that there are certain hormones in the body which we call as cortisols. So these are the stress hormones, and when we are exposed to very high noise levels, so these cortisols, the level of these cortisols, basically they increase in the body, and as a result of that we are having risk factors like blood pressure, even the blood lipids, blood glucose levels are also affected. And these disorders are manifested in terms of final disease like hypertension, which I think most of the Indian population is having, particularly those who are living in the metropolitan cities, maybe due to the lifestyle also, but due to the environment pollution also, we are having these types of diseases, and ischemic heart disease. So I think most of the older age people, and even nowadays, even younger people are exposed to these types of heart diseases. So noise pollution is one of the reason, apart from the other confounding factors. So now I move to the basics about the noise pollution, so that all the students or those who are doing some work in this regard, they can have a feel of how the noise pollution is measured. And then gradually I will come into the acoustic metrology, where NPL is specializing, and the testing activities that CSN NPL is undertaking, and how we propose that the problem can be solved. So decibel, I think the noise pollution, the unit of noise or sound is actually decibel, which is actually the logarithmic scale. And according to the scientific community, the decibel is measured as 20 log p by p reference, where p RMS actually is the incident incident root mean squared pressure that is incident upon the human ear, and p reference is always taken as the 20 micropascal as per the international standards. So the sound pressure level incident upon the human ear, if we can measure the p RMS, then we can measure the sound pressure level in terms of this fundamental equation 20 log p by p reference. So generally, basically we are measuring the sound pressure level in terms of a weighting which we call as the dBA weighting. Actually, that corresponds to how the human ear comprehends the noise. So generally, if you just see the pollution control board reports, so we will find that the sound pressure level is mentioned always in dBA. So that is generally a weighting that basically approximates the human ear response to the sound, because our human ear is basically more sensitive toward the middle and high frequency range. Low frequencies, which are we are not very sensitive, and as a result, so we generally use this type of weighting in our day-to-day research and daily life. So what actually this weighting is basically a filter that is being applied to the sound pressure level that is measured at various frequencies, and as a result of that we get a consolidated single number value, which I will share with you in the subsequent slides. So actually this rating devaluates the low frequency noise. You can see that at low frequencies 31.5, 63, we are having a very higher low frequency correction. So that is basically done because the human ear is very sensitive to the middle and high frequency range. So another weighting which we generally use is C weighting, which is actually used for the instruments which are generating very high sound levels, like the firecrackers or the toy noise. In fact, I think if you just have noticed the toy noise that our children are using, so they are having very high sound pressure levels. So generally for those types or aircraft noise, so for that we are using C weighting apart from the A weighting also. And Z weighting is a linear weighting where we have no applying no filter. This is generally used for the research purpose, but overall we are always using the A and C weightings. Now the basic terminology, how the sound pressure level is measured. Now if one asks a question that for instance, if I ask you if one has to measure a sound pressure level at a particular area, so maybe you will be you maybe you will raise a question that yes, definitely the sound pressure level will not be constant, because it will be changing. Maybe there are two vehicles coming at one point of time, but then subsequently a heavy truck comes or a heavy bus comes, and suddenly the honking is there. So how to measure this flickering type of signal? So as per the international standards, we are measuring an average value which we call as the RMS value, and that value is basically the time dependent. So say if we have to measure or we have to report a sound pressure level of a particular area in a time domain t, so then in that time domain, within a time framework for say the time of start is t1, maybe it can be 0 or t1, and then time of stop is time t2. So during this t1 minus t2 duration, we want to know the sound pressure level, the average or RMS sound pressure level of a particular area. So that is calculated by this equation, which we call as the equation for calculation of equivalent continuous sound level. So that is actually 10 log base to 10 divide 1 raised to 1 divided by tm. Tm is the time taken, and the same equation that we are using for sound pressure level. So from this, the LAQ is measured. So you can see it in this picture. In the flickering sound level, you are basically trying to calculate an RMS value, which is the fundamental measurement parameter for a varying source. And you basically, the researchers are interested only in knowing this value. Of course, there are other descriptors like the statistical parameters which tell us that how is the peak value behaving. But generally in our reports or day-to-day life, even if you watch the newspapers, or if you can see the CPCB reports or the pollution control body reports, so they are measuring this sound pressure level, equivalent continuous sound pressure levels. So that may be of duration, maybe of 1 hour, or it may be of the duration can be of 8 hours, or the duration can be more than 16 hours, or it can be for the whole day throughout 24 hours. So this is exactly the RMS value that I'm discussing. So this is the flickering sound level, and then this is the average value that is coming, that we are calculating using the above equation. So as I told you that this is actually the equivalent noise level. This is an energy weighting. So basically it can be of 15 minutes, it can be of 1 hour, it can be of 16 hours. Like in our standards, we are mentioned for daytime and nighttime. We assign the daytime as 16 hours and nighttime as 8 hours. And the significance of this exposure is basically, if the exposure is less than 3 dB, so there is a little subjective, the loudness is nil, and there is the change is very insignificant. But if it comes between 3 to 5, then it is noticeable. Maybe if you come across those dwellings which are very near to the metro stations, so sometimes they really notice that yes, metro train is coming. So the level of increase in that particular area is between 3 to 5. And then when it comes to more than 10 dB, so there the subjective loudness is almost double, and the change is very significant. And if it is coming more than 15, then it is really very high, very significant, just type of a gunshot burst, or maybe a cracker burst, which you can easily identify. So in that case, the sound pressure level is shooting up by more than 15 or 20 dBA, and you can easily notice that yes, some external disturbance has come into picture. So what is the basic instrument that is used for measuring the sound pressure level? So the basic instrumentation is the sound level meter or the sound level analyzer. And the physical principle behind this sound level meter is, it is actually the acoustical energy that is converted into the electrical energy, because the sound that is incident upon the human ear, that is also converted into the signals in our brain. And through our brains, we are trying to analyze the sound levels. That's yes, some external disturbance is coming, like honking is there, so we are able to correlate, yes, there is an external disturbance which is suddenly happened, and our brain will give us a signal, yes, something is there. And eventually we are just maybe frightened, or we just try to adapt ourselves due to that event. So similarly, based on that principle, the sound level meter is having the same principle, where acoustical energy is converted into the electrical current, which or voltage, which we are seeing in the display device. So the basic methodology behind that is, the block diagram of the system is, there is a preamplifier, and a weighting network is basically, this is actually the microphone where the sound is incident, and it is attached to a preamplifier. So this preamplifier is basically used to change the impedance of the incoming signal, and it from the high input impedance, it is converted into the low impedance, which is basically decoded by the weighting network. And from that weighting networks, as I told you, that A or C weightings is being generally used. So this weighting network functions in terms of applying a weighting or C weighting filter, which is then uh, amplified and rectified, and decoded in an averaging system, which basically displays the average sound pressure level during that particular time duration. So it consists of the transducer, the electronic amplifier, the frequency weighting, the data storage, and the display unit. So this is actually the picture of the sound level analyzer. Actually, this is a very high-end sound level analyzer, and it is a very costly sound analyzer which can do all sort of research work that we are using in our day-to-day research purpose in our laboratory. So you can see that the upper part, this is called the microphone, which is generally used to measure the sound level. So the whatever sound is incident upon this microphone is basically converting that sound signal into the equivalent electrical signal. And this is the part which is called the preamplifier, which is basically conditioning the signal. And this is the analyzer, and this is the display unit where we can get the complete details about the signal, that what is the sound level, what are the peak sound levels, what is the frequency spectrum, everything, whatever you want about. And even it can record for a duration of say 24 hours, like we are doing for the pollution control boards, which they are using these equipments and they're installing these equipments at a particular site, and then they are trying to record the sound pressure level at a particular at a particular site, and then they are trying to analyze whether the levels are within the limits or they are higher than limits, and how to control those levels. So as I told you that basically the condenser microphone, basically it is behaving as a transducer, which is basically, this is actually called the grid of the microphone, which is basically attached on the upper surface of the microphone to protect the microphone from the external dust or maybe from the harsh weather conditions. So whenever the sound pressure level is incident upon this microphone, so you can see there is a diaphragm here. So this diaphragm is basically vibrating when the external sound pressure level is incident, and there is a change in the due to the change in the displacement, there is a voltage generated in this diaphragm. So that voltage is basically analyzed in the analyzer, and from that we can measure the equivalent dB level, right? So there are various types of sound level meters that are coming into market. I think most of the people are using type 2 because in the laboratory and for the research purpose and for the pollution control board, we are generally using type 1. Type 0 is and type 1 are general purpose. Basically the laboratory use equipments, as I am showing this type of equipment. This is actually a type 1 or type 0 instrument, which is generally used for research purpose and for precision measurements. But there are type 2 which are very low priced, and I think there are very cheap quality equipments are also available in the market, which may mostly our DG set manufacturers or some of the even some of the pollution control boards they are having, just to analyze that what sort of noise pollution is there. And type 3s are there which are a very high having very high too wide tolerances, but these are not generally used. And this is actually the ANSI standard which shows the which gives the detail about these type 1 type 2 instruments. And in Indian scenario, basically we are currently manufacturing type 2 types of instruments, but type 0 and type 1 instruments are not manufactured. So CSIR NPL is basically taking a lead in this regard, and we have ventured with a government organization called WEBL, West Bengal Electronic Corporation Limited, Kolkata, and we are trying to develop an indigenous type 1 system under a consultancy project. Now, as you know that whenever there is a signal, so that is electronically, that is analyzed in terms of time domain and a frequency domain. And all of you know, maybe some of you have read about the fast Fourier transform. So that the same FFT analysis is done in the sound level analyzers, because we need to have a time domain signal also, and we need to do the frequency domain analysis also to find out which frequencies are mostly dominant in the noise source. So if you can see this spectrum, this is a spectrum of actually a metro train which is coming to the metro station and undergoing a braking. So from the signal, if you just analyze this type of signal, this is actually a frequency domain analysis from 20 hertz to 20 kilohertz, which is the audible frequency range of the human ear. Below 20 hertz and above 20 kilohertz, generally human ear cannot hear the noise. And some of the animals, some of the birds like bats, they can hear the low frequency noise and high frequency noise. So if you can see the signal, you can see that in the middle range, the sound pressure levels are higher. In the low frequency range, also some sound pressure level are higher. And if you can see that the high frequency range at 20 kilohertz, the level is very high. So from as an acoustician, I could now correlate that what types of sources are there while the metro train is undergoing braking, so as to correlate that what is the culprit of this high noise levels. Because if you can see that if I can control all these levels, so basically my sound pressure level will be controlled. So it will be reduced, and the source will be less noisier. So in the middle frequency range, if you can see in this range from 250 or maybe 315 hertz to 800 hertz, in this range, the noise level is generally higher due to the rail wheel interaction, because there is a friction, and that rail and wheel interaction causes high sound pressure levels. But at the high frequency range, somewhere around 20 kilohertz, this is basically due to the braking noise. And I could correlate that there is a flanging basically between the when brake is being applied, and due to that, the high frequency squealing noise is basically encountered. So FFT analysis is a very important part, an integral part in noise control, because an acoustician can only understand about the signal while doing the FFT analysis, and from that he can try to analyze how sort of control measure can be adapted to control that noise, so that the source can be made less noisier. So this frequency noise analysis is somewhat different from what we are doing in the routine FFT analysis, because in acoustics we are basically focused on octave and 1 by 1 octave and 1 by 3rd octave band analysis. So actually this is an international practice that is being followed, where we are basically trying to use the frequency domains in terms of the upper frequency and the lower limit. If you can see this equation, Fu by Fl, where Fu is the upper limit and Fl is the lower frequency limit, and this is correlated in terms of 2 raised to power 1 by n, where n is 1 for 1 by 1 octave and n is equal to 3 for 1 by 3rd octave. So this is just a 1/3 octave band analysis of the metro train noise that I was telling. But if you want to squeeze that, if you want to have a narrow band analysis, so maybe you can use a 1 by 1 octave. So how that is there? This you can see, as I was telling that there is a upper upper frequency limit FL. Then there is a second, the lower frequency limit FU, and the center frequency is calculated as the square root of upper limit multiplied by the lower limit. I think this will be more clear if you can see this slide. So this is octave band analysis, where you can see if we start with from 31.5 hertz, because below that we cannot hear. So the 31.5 multiplied by 2 gives you 63, then multiplied by 2 gives you 125, and so on. So you are multiplying with by 2 and you are getting the complete range up to 16,000 hertz. But for the lower, for the 1/3 octave band analysis, it starts from 20 hertz. The first range is 20, then comes 25. So 25 is actually 20 multiplied by 2 raised to power 1 by 3. And similarly, 31.5 is calculated as 25 multiplied by 2 raised to power 1 by 3, and so on. So the beauty for the 1/3 octave band analysis is that the whole human audible frequency range can be characterized in this particular octave 1/3 octave band analysis. And generally, for our research purpose, we are using 1/3 octave band analysis. So as I told you that we have our limits also. So the Central Pollution Control Board of India and the Ministry of Environment and Forest and Climate Change, they have endorsed a limit which we call as the noise pollution control rules that were enacted in 2000, and subsequently there have been some amendments in those rules. But still it is, I think, maybe 2000, since 2002 they have been going on. So they have defined 4 areas. One is the uh, industrial area, the second is the commercial area, third is the residential area, and 4 is the silent zone. So this is upon the competent authority to basically discretize an area into industrial, commercial, residential, or silent zone, and this lies upon the basically the district administration or the police authorities. But the limits are basically specified as 75, 65, 55, and 50 for the daytimes. And similarly, uh, 70, 55, 45, and 40 for the night time. So as per the rules, the daytime is from 6 a.m. to 10 a.m. and for the night time it is from 10 p.m. to 6 a.m. So the silent zone, residential zone is the most critical areas, because we are living, our hospitals, our schools, our colleges, our even religious places are basically lying in the residential and silent zones. So this is actually characterized as the area comprising not less than 100 meters around the schools, hospitals, educational institutions, courts, religious places, etc., which is declared by the competent authority. So as per the rules, these are the limit. But unfortunately, if you just try to measure most of the areas in our NCR region, they are not complying with these limits. So we have to really work hard and we have to really focus on how to control our noise levels. And believe me, the government of Delhi as well as government of the central government, they are really very serious. And as in my subsequent slide, I will show you that how they are trying to work on this regard and how to control the noise levels. So as the rules are there are certain subset of the rules which are, I think there is a long list. If one is interested, they can visit the CPCB website where all these rules about various sources of the noise pollution are there, and you can just try to understand that how these sources are characterized and what levels are being, what limits are being endorsed for them. Like it prohibits the use of loudspeakers and public address systems in the closed premises. And I think if I think 4 or 5 months back, so there was a lot of media coverage on that loudspeaker and public address systems. And it, according to the rule, it limits the increase of sound pressure level at a boundary of the public uh, place up to 10 dB. Limit the increase of peripheral sound pressure level in a private owned system up to 5 dB. It prohibits the use of honking during the night time, especially in the residential areas. Prohibits the use of firecrackers during night time. Prohibits the use of noisy construction equipment during the night time. So all these rules are framed, but unfortunately, it is up to us that how whether we follow these rules or not. Like this time, even in Diwali also festival, the government of Delhi has really enacted various rules that we don't have to burst the crackers. But unfortunately, in the next day, the newspaper was mentioning that levels were very high, as people really they have come out at their homes and they have really busted a lot of crackers. So not only from the government point of view, it is our role also, it is our initiative also. As a common man, we have also to focus that we should not create our environment noisy. We have to look about our environment. It should be the ambience of the environment, that it should not be polluted. So when it comes to characterizing the various sources, so all of know understand that yes, transportation is a very serious part in that. Then construction of buildings, highways, they also use of heavy equipments, compressors, bulldozers, loaders, dumping trucks, etc. Industrial noise also is a very important issue. Loudspeakers, plumbing, boilers, generators, etc. Air conditioners. So these all sources of noise pollution are there. Even these domestic sources, like we are using vacuum cleaners, mixies, grinders, in condition and other air conditioners, etc. in our homes. So when it comes to noise control, so basically the noise control is a very integral part then which an acoustician has always to focus, because just monitoring the noise levels, understanding the doing the analysis will never give you anything, because you need to focus on how to control. So basically, as I was telling, that basically from the level, frequency and duration, we could make out that how we can control a noise source, how we can prevent, how we can minimize the noise levels. So sometimes from the presence of characters like the hiss, screech, or whining noise, that is basically coming. If maybe if you have, sometimes you are standing near a metro train, and suddenly the metro train is coming and you are trying to hear a screeching sound when it is brake is applied and it is just decelerating and immediately coming to a stop. So you can make out that what sort of a signal is there, what character is present, whether it is due to the low frequency noise or maybe due to the high frequency noise, and how we can, what measures we can adapt so that we can control this type of screeching noise or whining noise. Sometimes even we when we are at homes, so we are basically hearing a rattling type of noise in our homes. So that is basically uh, uh, sometimes we say that yes, our इसे हिंदी में हम कहते हैं जैसे दीवार बात कर रही है, so that is actually audible type of rattling noise, which is basically due to the vibration of the buildings that is basically coming to us. So the cost of noise control measure is very directly related to the criteria selected, and we have to focus on this regard. The modern noise control techniques basically stipulate three basic control measures. So one is the reduction of noise at source. So source means you can control the vehicle. If you can control the vehicle, if you can use a very, say, if you can use a very good silencer, or maybe if you can use a multi-point fuel injection system for a car, so you are controlling the source itself. And basically that is the easiest way when you are controlling the source itself. But obstruction in the propagation path, that means you are basically creating an enclosure over the equipment, so that the noise is basically due to that enclosure, the noise is not coming out. Or maybe if you are using a noise barrier, which we are generally mentioning that yes, noise barriers is the need of our, particularly for the silence and residential zones. So that is basically a physical wall that you are basically creating between the noise source and between the receiver. And the third end is the receiver end. Receiver end, that means the treatment at our homes. Maybe if you just come across with the if you have ever analyzed that in our modern cars we have a double glazed windows in our windows actually. So these sort of treatments can give you a better sound insulation at our homes, and we will be able to restrict the outside noise to a greater extent. However, the most effective measures generally are at the source itself, because if you can control the source itself, then our half of the job is done. Creating the noise at controlling the noise at the path or at the receiver, it is not very cost effective, and generally noise barriers are used in the propagation path. In fact, if you have ever analyzed those people who have traveled to Europe and American continent, you can see that in the residential zones noise barriers are widely used, but in Indian context these are not very much used in India. So we have to have some policies where we can develop some noise barriers which can be environmental friendly and which are used at our in highways and our roadways, so that the dwellings are really they are less prone to the higher noise exposure levels of the traffic. However, there is a fundamental principle that barrier is only effective when it is near to the source or receiver. So that is actually a thumb rule basically when we are designing a noise barrier. And CSIR NPL has basically uh, uh, given a lot of consultancy jobs in terms of this effect in this regard. In fact, I remember that in 2009, the Commonwealth Game Village was there at the Akshardham site. So the noise barrier was designed by CSIR NPL at that particular site, and as a result of that, so the noise levels were subsequently reduced to a very great extent. Then windows basically at the receiver ends, as I was telling you, the double glazed windows, if we can use, so that can also prevent greater noise pollution in our homes. If we can if we characterize the noise control, so basically there are two methods. One we call as the active method, and other is we call as the passive methods. So active method is basically the use of digital signal processing, and here more of electronics is involved. But unfortunately, in Indian context, this is not much used, because a lot of this is not a very cost-effective option also, and it requires a very high electronics in that. But passive methods are widely used, in fact, in all parts of the world. So basically, that is use of insulation, silencers, vibration mounts, damping treatments, and it works at the middle and high frequencies. And it can be however, it can be bulky and heavy when used at the low frequencies. So as I was telling you about the noise barrier, so this noise barrier is basically, you can see that this is a source, and it is generating a noise level at this is he's using a loudspeaker, and that is an omnidirectional loudspeaker which is generating a sound levels in various zones. So if we are erecting a barrier basically, and this is the receiver, so he is basically uh, uh, this receiver is the sound level coming to the receiver is attenuated to a greater extent, which you can see from this block diagram. So generally this type of noise barriers come into picture when we are not able to control the noise at the source. But then there are certain limitations also, because we cannot use noise barriers as such, because there are sometimes very issues even due to the parallel walls of the facades. So sometimes reflection can be there, and indirectly it generates a higher noise levels. So while designing a noise barrier for a particular area, an acoustician has to really think of various pros and cons before giving a particular recommendation about the using of the noise barrier. So as I was telling, that government of India is not, as people say that what government is doing. So really, I must say that government is really very serious on this aspect, and they have eventually taken a lot of serious steps on this regard. So this was in the year started in 2011, when the Central Pollution Control Board, in collaboration with the Ministry of Environment and Forest and Climate Change, they have established a National Ambient Noise Monitoring Network. The short form is NANMN, and this was started in year 2011, which was basically, the objective was to set noise monitoring terminals in the various parts of the country, so that we can get the noise level data throughout the day, throughout 24 hour day, throughout a year. So these, if you can see the picture of this terminal, this is the noise monitoring terminal, which is basically erected at one of the site in Delhi. And this is using a class 1 microphone, and this type of microphone is an outdoor microphone which is environmental friendly, and even rain or harsh weather conditions cannot affect this type of microphone. And this box is basically housing an analyzer which is basically getting the old data recorded, and that data is connected through GPRS interface to the central processing station at Central Pollution Control Board, and they are able to decode that data and analyze that data and make their reports that what is the noise level at that particular site. And even this system is having a facility of solar panel, so whenever the external power is not there, the system can work independently without the power, and it can work on solar panels. So initially this system was set up at 5 sites in Delhi. One was at CPCB office, then Dilshad Garden, then at Delhi Technological University, the Netaji Subhash Institute of Technology, and ITU. But subsequently, these 5 sites have now increased up to 10 sites, and these types of systems are stationed in 7 major cities of the country, and around 70 stations have been now installed, which since 2014, I think, and they are continuously 24 hours into 365 days. They are giving the noise levels of those particular sites, and I think now the government is very serious, and they have a very ambitious plan to increase the stations to from 70 to, I think, maybe more than 180, or maybe even higher. So in that way, we are getting the continuous noise monitor data for our residential zone sites, the silence zone sites, the industrial zone sites, and the commercial sites. And we can analyze that what types of noise scenarios there, and how we can adopt the noise control techniques so that we can prevent the noise pollution. If you just analyze the data, this was just an analysis that was done by my research scholars since year 2017 and 2020. So you can just analyze that if we comply with, if we just try to analyze the compliance with respect to the CPCB limits. So only the industrial sites are qualifying these standards, because the limits are really very high, 75 and 70. But when it comes to industrial zone, residential zone sites and silence zone sites, so those sites are not qualifying the ambient noise standards. So because we have a stringent limit of 55 and 65, even for the commercial zone sites also. So maybe we have to focus more on the residential zone sites and silence zone sites, so that where we are, the environment where we are residing, that should be environmental friendly and less noisy, so that we are not affected due to any health effects. And again, the government of Delhi also, they have also an ambitious program in this regard. And sorry, so maybe this slide is not coming. So the government of Delhi has also set the DPCC, the Delhi Pollution Control Committee. They have established 26 noise monitoring terminals in various parts of Delhi since year 2020, sorry. And that is also continuously undertaking the noise measurements throughout the day, throughout the night, and throughout the year, and which is giving the data. And if you just analyze from that also, this is just a single day analysis, you can see the residential zone sites and silence zone sites are really affected. So our major focus should be particularly for these residential and silence zone sites, so that we can prevent noise pollution in these types of sites. And as a role, as CSIR NPL is also doing a lot of studies in this regard. Two of my research scholars, they are doing their doctorate in this field, and they have been moving here and there in various parts of Delhi city. And last year we observed a noise awareness week from 18 December to 25 December, and we covered around 100 sites in Delhi, just to inculcate awareness among the people. So we used hoardings and banners, and we try to make people aware about the ill effects of noise pollution, and we measured the noise pollution at various sites. So we could observe that most of the sites were having noise levels, hourly noise levels, more than 65 to 70 dB. So that is an alarming situation in our part, and we really have to work out to prevent the noise pollution in our metropolitan city. But when it comes to European scenario, if you can see the European Environmental Action Program, uh, where this was a program enacted in 2020, and where they basically, it was, the theme was living well within the limits of our planet. So there was a directive undertaken by in 2002 by all the member states in Europe region, and according to that directive, uh, uh, three strategies were followed: that you have to do the noise monitoring, then you have to undertake the noise mapping, and you need to have action planning in the 5-year cycles. And even subsequently, a guidelines development group of in the Europe region, they have come out with a stringent norms. If you can see the road traffic noise limit, they have endorsed at 53 dB LDN. Actually, LDN is the day, evening, night sound level. Generally, in our country, we are basically focused on day and night noise levels, but in Europe, they are focusing on day, evening, night noise levels. So if you can see the limits, these are very stringent: 45 dB L night and 53 dB LDN. Similarly, for the railway and aircraft noise, I think in Indian scenario, it is very difficult to get to these limits, but they have a very ambitious plan, and they are trying to conduct the noise mapping and action planning for every 5-year cycle, so that they can reduce the noise levels and get on to these limits. So before I move to the further part, let me just tell you what is a noise map basically. So this is a new technology that has been eventually come out in the European and American content. Although the Europe has been focused on this technique since 2002, when the directives came into part. So noise map is basically a graphical representation of the sound level prevailing in a particular area. So by just color code analysis, if you can superimpose a particular area, the area, the digital plan and elevation of a particular area, and if you can just using a color code, if you can use a pictorial view, or maybe you can give a color codes about the noise levels, so you can identify which are the critical areas, which are the noisy hotspots, and how we can control the noise levels in those areas. Basically, the technique is basically focused on two methods. One we call as a grid method, and other is called the categorization method. So grid is basically you are trying to analyze a grid of a particular area superimposed. Say if you are taking a case study of East Delhi. So basically you are taking the map of the East Delhi, and you are trying to develop to draw some grids on that map, and from that grids you are basically trying to monitor the noise levels at the corners of the grid and trying to make a plot like this. But categorization is basically you are trying to categorize in terms of road, basically maybe the heavy traffic roads, maybe the medium traffic roads, or the low traffic roads, highways, etc. So what is the use of this noise mapping? Noise mapping is basically focused on, either you can take the actual noise measurements, or you can use a noise model, and you can develop such a map like this, which is shown in the picture. The benefit of this is that we can identify the hotspots, we can do the noise sources identification, even we can identify the number of the buildings and people who are affected by the noise pollution. And this technique is widely used in the developed countries, and they have certain action plans, and they always revise their maps after they initiate the action plans. Now, this is just a pictorial view, just an example to show you that this is a noise map that I have just developed with the help of my students for CSIR National Physical Laboratory. For those of you who have visited CSIR NPL, so you can just see that this is our main gate, and opposite to that is the NPL colony. And this is the actually main gate, which is nearby. The gate is parallel to the road, where vehicular density of around 3,000 vehicles per hour is there during the peak here. And in between the laboratory, although we are very cautious about the noise levels in the laboratory, and we have a very lush green campus, but I could identify some of the critical areas also. Like this was a particularly the near the Apex Meteorology building. There is the AC plant is there, so that is creating a noise level. But there is no technical solution to that, and we are generally covering that AC plant through the doors and windows. So as a result of that, we that noise is not basically affecting our meteorology building. So, but definitely you can find out what are the various sources of the noise pollution in a particular area, and then you can take a preventive action. So I use a color code. You can see that as and when the noise levels are higher, so you can maybe dark colors can be used. so as to identify those hotspots in your map. So in Indian scenario, actually, this noise mapping is at a very primitive stages. But now, in 2019, there was a draft on noise mapping that was developed by Central Pollution Control Board, and CSIR NPL played a lead role in this regard. Actually, we developed the draft for the noise mapping. That what should be the guidelines for noise mapping, because noise mapping is not very easy as it looks like. Developing a noise map for a particular city or a particular area is not very easy, and you need to have various strategies that you have to focus for developing the noise map. So we developed a noise map, and we developed a draft for that noise mapping, and then we CPCB subsequently circulated that draft to all the pollution control boards in the country. And then CPCB also endorse all the pollution control boards to take up some studies, to take up some joint collaborations with the private industries, with the government bodies, to draw the noise maps in their cities, particularly for the noisy cities, and take a remedial action plans so that they can prevent the noise pollution in the cities. And in fact, CSR NPL also participated in various tenders, and eventually all these studies are coming out, like one for Ludhiana and Amritsar. CPCB has directed the Punjab Pollution Control Board, and already a study has been initiated and has been done. I think that study is almost completed for the two cities of Punjab pollution in Ludhiana and Amritsar. Subsequently, many cities like Rajasthan, then Gujarat, four cities in Gujarat, they are also undertaking sort of noise mapping. And now, in recently also, the Central Pollution Control Board has come up with a study for Delhi city also, wherein they are planning that for 170 sites in Delhi city, the noise mapping will be undertaken, followed by the remedial action plans. Apart from that, the government, the Central Pollution Control Board, the Ministry of Environment and Forest, the based on the guidelines of National Green Tribunals, have developed various committees on the national scale and on the local scale also, where the police, the municipal corporations, even judiciary, they are the part of that programs, and there the certain laws and legislations are being framed, and CSR and NPL is also playing a lead role in that, to basically to help them to frame the rules and regulations and provide technical solutions so that the noise pollution can be controlled to a good extent in our metropolitan cities and tier 2 and tier 3 cities. So unfortunately, the issue behind the noise control is that we are left with a very only a few methods where we can control the noise levels. As I was telling you, that noise barrier is one of the important option in this regard, where we can get a 3 to 20 dB. This slide shows the cost benefit analysis, because as a developing country in India, we need to focus on the cost effectiveness of the measure also. And uh, this is slide that basically I've tried to analyze in terms of cost benefit analysis. So you can see that noise barrier is very cost effective, but sometimes it is costly also, because the attenuation provided is a good at a very good level up to 20 dB, but the cost consideration sometimes come into picture, which really creates a hurdle in our uh, in that mitigation strategies. Then some like building insulation, quieter road surfaces, low noise tires, building design, traffic control. So these things are also, these things can be considered as a probable solution for noise pollution control in our cities. Now I come to the role of CSR NPL. Basically, although acoustic metrology was the first part of the topic, but I thought that just I could go for the introduction about the noise pollution, and then I come to the major role of CSR NPL in terms of acoustic metrology. So CSR NPL, as you know, is the National Metrology Institute of the country, and we are bestowed the responsibility of establishment of the national measurement standards. We are doing the R&D on the metrology, dissemination on the national measurement standards, and inclusion of the measurement capabilities in the BIPM websites. So these all are the activities that CSR and NPL is undertaking. And in the field of acoustics and vibration metrology department also, we are doing all these activities so as to benefit our industries, our society, and all the key stakeholders. So as I was telling, so we are maintaining and realizing the standards of sound pressure level in the entire country. We are providing the calibration and testing activities in electroacoustic equipments and materials, R&D in the noise monitoring and control, and we have covered we have completed various sponsored and consultancy projects since past 3 decades in this regard to help the government of India, to help the various private industries, state pollution control boards, central pollution control boards for noise pollution prevention and control. And CSR NPL is not only in Indian context, but we are internationally recognized also because we have 34 calibration and measurement capabilities in BIPM website as on today, and we hope that this will be increasing up to 45 in due course of time. So if you can see the international status of CSR NPL in the APMP region, so this is actually the last year technical committee on acoustics, ultrasound and vibration was held, and I was really fortunate to participate in that meeting. So as on November 2021, this is the status of all the countries in Asia Pacific region, and you can see that our role is we are at a very good position, having 34 CMCs, and even some of the developed countries, they are having lesser CMCs than us. And recently we have upgraded our systems, and we are hopefully in the next 3 to 4 years this range will be increased from 34 to 45 at least. Before just going on further, maybe those students who have joined this workshop, so maybe just to apprise them that what is the basic concept about metrology and CMC. So just to brush up their knowledge, metrological traceability is actually the property where you are basically linking your measurement to a documented chain of calibrations, each contributing to the measurement uncertainty. So as you can see that this is actually a pyramid of, for those who have visited NPL, so they must have seen this pyramid at the in front of director bungalow and this type of globe. So we basically, as I told you, that NPL is bestowed the responsibility of maintaining the national standards and at par with the international standards, and to realize the 7 fundamental units. So basically at the apex level of this pyramid comes the CSR NPL, the NMI of the country, the National Metrology Institute of the India. So we are bestowed the responsibility of maintaining the primary standards. Then we realize the secondary standards, which can be realized by NPL also, which can be realized by the regional laboratories also, which are traceable to the national standard. That means these secondary standards are calibrated by the primary standards, and primary standards basically by participating in the key comparison exercises with the other NMIs, we are basically validating our, or maybe sometimes doing in-house calibrations from our other respective department, like the dimension standard, or maybe the temperature standard or the voltage standard. So we are trying to take traceability for our primary standards. And the reference standards, these are basically either calibrated by the secondary standards or primary standards, and these can be either through the NMI or maybe through the regional laboratories. And then comes the working standard and the measuring instruments, which are being used by the all the stakeholders, the industries, the pollution control boards, the researchers, everybody. So these all are traceable to the national standards. And if there is this chain is broken, so the traceability is basically lost. So you can see that the traceability is very important to the national standards. And if you can see the quality infrastructure of the country, so that depends upon how the traceability chain is there. So if we can link all the measurements that we are undertaking for the parameter of sound and vibration to the national standards, I think we have a great role in this regard. So again, one thing for the students, those who don't know the calibration and measurement capabilities, actually CMC is basically in a layman language, it is a sort of recognition to any laboratory in international scenario, and it is available to the customers under normal conditions as defined in the International Bureau of Weights and Measures. We call it as BIPM, and it is published in the BIPM Key Comparison Database and Mutual Recognition Agreement, and it is actually the laboratory scope of accreditation granted by the ILEC. So that is basically a laboratory scope of accreditation, and we have a specified uncertainty for that, and the measurement is documented. The measurement is as per the international protocols. So all these things are there, while CMC is a laboratory is granted as CMC. And if you go for a international CMC in the BAPM website, is a really a very toughest job that a laboratory could have. And once you have a CMC, then you have a recognized at par with the other countries of the world through the mutual recognition agreement. So this, as I was telling you, this is the status of CSR MPL India in all the country across the globe. So you can see some of the countries like Brazil and South Africa, they have very high CMCs, but India is also at a very good level. And we hope that with next due course of time, we'll be getting up to at least 45 to 55 CMCs. So as I was telling you about CMCs, I think, so now I come to the picture, how we are basically conducting the acoustic metrology. So while doing metrology, we need to know what is actually the laboratory artifacts which are being calibrated by the primary standards. So these are called the reference standard microphones. Just to make you acquaint about that this is actually a reference standard microphone which we call as LS2P, where which is LS is the description about the laboratory standard, P is for the pressure field or free field, and 2 is whether this is 1 inch or half inch. So these types of the reference standard microphones are used for providing traceability to the for the parameter of sound pressure level to the entire country. So we from these laboratory standard microphones, we are calibrating the working standard microphones, which we call as WS, and these are also designated similarly as the laboratory LS2P or WS2P or WS2F, where P is for the pressure field and F is for the free field. So you can see the picture of these reference microphones. This is a 1 inch microphone and this is a half inch microphone. These microphones are very stable microphones, and these are used for calibrating the entire measurement of sound pressure level undertaken in the country. From these microphones are calibrated these working standard microphones, which we are using in our day-to-day measurements. So these microphones are responsible for disseminating the traceability in the field of sound pressure level to the entire country. So basically, actually, we are using two units in that. Basically, as I was telling you, that these laboratory standard microphones or the working standard microphones, these are actually the transducers, where when the sound pressure level is incident, there is a change in the voltage. So the sensitivity of the microphone is basically measured in terms of voltage divided by the applied sound pressure level. So that is sometimes measured in terms of the pressure sensitivity, which we call as the voltage output divided by the input pressure. So that is the unit is dB reference 1 volt per Pascal. So from our in the calibration, we are basically measuring this type of physical quantity in terms of dB reference 1 volt per Pascal. Now the free field acoustics comes into picture actually, because sound is basically omnidirectional. So it is a spherical wave. So it is basically the noise source is affecting the sound. It is emitting the sound in all the directions, and particularly it is actually a free field. We call it as a free field where the sound is completely absorbed by the environment. And we have some facilities which we call as the anechoic chamber, which are specially designed to have 100% absorptive walls, so that we can generate a free field uh, uh, field in the particular environment. So we have free field microphones which are specially designed in such a way in this type of environment where we can measure the sound pressure level, and these are designed in such a way that they do not interrupt the sound measurements, because the microphone grid comes into picture. So we are trying to basically these are designed in such a way that the microphone, the sound pressure level of the incident upon the microphone is not affecting the actual sound pressure level of the field. Then we have a diffuse sound field. Actually, you must have encountered when you are basically in a closed area. So there is a reflection is there every time, and that basically generates a diffuse field. So underground tunnels, if you have experienced when train is moving in an underground tunnel, suddenly the sound pressure level is very high. So basically that is due to the reflection of the sound pressure level. So we have a diffuse field microphones also, and we have a specialized environment which we call as the reverberation chamber. So that is basically meant for those type of measurement. And my colleague Dr. Chitra Gautam will discuss about those type of testing activities in subsequently in this presentation. Now there are various types of calibration methods. One is the closed coupler method, where we have a closed coupler cavity to provide calibration services. And I think this is used by all of the NMIs of the world. So actually that is actually a coupler is basically a half-inch coupler is made, where we are basically exposing our sound level meters to a certain sound pressure level, and it is being calibrated. I'll just show you in the next slides. So as I told you that there is a free field microphone, then there is a pressure field microphone and a diffuse field microphone. So generally free field microphone is used for the general measurements, but pressure field microphone is generally used for the pressure response of the microphone in a closed coupler, and these types of calibrations are generally used, and then free field corrections are applied to that, so that we can indirectly measure the free field response of a particular microphone. So as I was telling you that these are the pressure field microphones, and you can see that when the diameter of the microphone is less, the frequency range is higher. So smaller the microphone, greater is the frequency range. So both these microphones cover the range from 20 hertz to 25 kilohertz, which is the audible frequency range of the human ear. When it comes to the calibration technique, so we have the reciprocity calibration method, which is the primary method for calibrating the microphone. Then we come for the secondary method, which we call as the substitution method, the piston phone or the sound calibrator approach, which I think most of the laboratories know, and electrostatic actuator calibration for the calibration of the working standard microphones, which we are generally using for our day-to-day measurements. So reciprocity calibration, this is actually used for the primary method. Just to give you an idea, actually this method uses three microphones, and this type of this is actually the facility of CSR NPL. Now it has been upgraded recently, and on in just 1 week back before Diwali, we have a new standard now, and this standard is at par with all the countries, and now our frequency range is enhanced from 1 hertz to 25 kilohertz. So we are at par with other countries, and right now we are undergoing a key comparison with the Danish Fundamental Institute of Metrology, a specialized laboratory is there called DPLA, Danish Primary Lab of Acoustics. And once we have a good performance in that key comparison, then we'll be able to establish our CMCs for the entire range from 1 hertz to 25 kilohertz. So this basically, as I was telling you, so these are the reference standard microphones which are calibrated over this system, and these are the working standard microphones which are calibrated to these types of microphones. And you can see the order of the uncertainty is somewhere between 0.05 dB to 0.17 dB. So I hope you can appreciate that this is the level of the uncertainty that we are maintaining for these types of reference standard microphones using these primary standards. And this is at par with the other countries. We have our system is now at par with the, in fact, most of the developed nations in the world. So basically, as I was telling you, just to give you a brief idea what is actually the reciprocity calibration, which is used for the primary method. It is actually consisting of three microphones. As you know that microphone is a reciprocal transducer, because it can generate the sound pressure level also, and it can receive also, it can analyze also. So here we are using three microphones basically. So this type of coupler cavity is there. So where one microphone we use as a source and another microphone is called as a receiver, and we are generate, one is used to generate a sound source and another is used to generate to analyze the sound pressure level. And as per the reciprocity method, there is the physical principle is that the product of the sensitivity of the two microphones is equal to the ratio of electrical and acoustical impedance of the two microphones. So these acoustical and electrical impedance of the microphone is measured electrically through the circuit, where we can we can measure the current flowing and the voltage output when the microphone is subjected to a certain sound pressure level. And this is basically the glass jar, where you can see that these two microphones are coupled with a coupler cavity, and these are calibrated using the primary standard. So if you can see the picture of the primary standard, sorry, I don't have the new picture, and this is for the older system we had. So you can see that this is the glass jar, and it is connected to the heart of the system, which we call as the calibration, the analyzer, and this is the sign generator and the band pass filter and the voltmeter. Now the system that we have, these three things are coupled in one single analyzer, which is basically the heart of the system. And then it is connected to the PC, and the whole system is automated, and we have to just take the measurement. But the process is very cumbersome. It takes around 1 or 2 days to complete the entire set of measurement for calibration of the microphone. So this is how the traceability in the parameter of acoustics is there. So at the PEX level, you can see the primary standard microphones are there, and this is undergoing, this is drawing the traceability to the temperature, mass, and other departments. And then secondary standard microphones are calibrated through the primary standard. From this, we are calibrating the acoustic calibrator, piston phone, sound calibrators, through which we are calibrating our sound level meters, which we are using for day-to-day research, laboratory activities, pollution control board, industries, etc. So when it comes to the secondary calibration, basically that is a comparison calibration, and sometimes substitution method is also there. But in our country, most of the laboratories, because I am an enable assessor also, so I have conducted audit of almost all the laboratories, and I'm basically most of the laboratories in India, including NPL and the leading laboratories at the regional level, ARI, FCRI, Palakkad. So they are all having the comparison method. So actually the comparison method is based on either using a piston phone or using a coupler. So you can see the picture. This is actually a sound calibrator, or this is a piston phone. The difference between them is basically it is generating a 94 dB or 114 dB signal, and piston phone is generating a 124 dB signal. So this is how you can mount your sound emitter in this cavity, and you can measure whether it is measuring 94 dB or 114 dB or not. So electrostatic calibration is actually used for the calibration of the microphone in the entire frequency range, and it is basically based on a particular voltage is applied, a DC voltage and AC voltage is applied to the microphone, and an electrostatic field is generated, and from that we can calculate the frequency response of the microphone, right? So this is how the calibrators are being used for calibrating the sound pressure level. So maybe actually this is not a complete calibration, but this is just a spot checking of your sound emitter, whether your measurements are right or wrong. So this is actually the clear-cut picture of how we are with the uncertainties figures, that how we are maintaining the traceability chain in the country. So as I told you that the reciprocity calibration is used for calibration of the reference standard microphones. Then comes the sound calibrator piston phones, measurement microphones, which are calibrated through the reciprocity methods. And from that we are calibrating the sound emitters, analyzers, and we are undertaking sound transmission loss testing also for acoustical materials that my colleague Dr. Chitra Gautam will discuss. So another part that is very important from the legal metrology point of view is actually the characterization of the sound sources, and for that, as I was telling, is the anechoic chamber is a very important part in that. So this is basically a free field environment where we are testing the sound pressure level or sound power level of an equipment. Generally, as you know that while you are basically when you are taking an electrical equipment, so you are always focused about the wattage in electrical watt of the equipment. So similarly, and as an acoustician, we are always concerned about the acoustical power output of a particular system, and that has to be measured in this type of environment, which we call as the anechoic chamber, which is perfectly absorbing. So there are certain ISO standards over that, and from that standards we can calculate it, the sound power level output of the machine. So so these are the three standards which actually tell how the sound power level has to be measured. So I'll not go in details because there are other slides also that are pending, and we have a limited time frame. So this is used for characterizing all the type of noise sources. And in just one of my research paper, because Europe is very focused on this particular regard, like the Bureau of Energy Efficiency, they are now characterizing the energy rating on the domestic appliances. Like if you go for uh, buying a air conditioner, so you are always seeing the Bureau of Energy rating is there. So why not about the acoustic power output of a machine? And this has been now endorsed in the Europe, but in Indian condition, I think we have to come out with these types of legislation due course of time, so that we can reduce the noise emitted to the domestic appliances. So this was just an idea, just a sort of type of symbol that I propose that these types of symbols can be there in the future when we have some gazette notifications where we can just identify the power output or the sound pressure level of a machine. And maybe customer can be then they have a, and the industries will have then a very good competition about whether they have a quieter instrument or not. And maybe in future people will be really worried that if that they will really like to buy an equipment which is creating less noise sound power levels. So as I was telling, the calibration of sound calibrator is a very important part in our country, because most of the labs, they are taking their instruments, they are getting the sound level meter calibrated from the sound calibrator. But sound calibrator is actually this is a comparison calibration, and where we are comparing the voltage output of a sound calibrator with a reference calibrator. So we have the system for that also, And this is actually based on a technique called the insert voltage method, where the microphone that is being calibrated is calibrated using the reference standard microphone, which is calibrated by the primary standard, and both are excited to a certain sound pressure level, and the output is measured through a frequency analyzer and voltage analyzer. So we can calculate the sensitivity of the unknown microphone or the device under calibration by using this system. And this calibration of the sound level meter is an important issue, because nowadays the noise monitor terminals are coming into picture in almost all the cities of India. So we are also trying to develop a particular system in this regard, and the system development is under process in our anechoic chambers. The system will be able to hopefully characterize the free field response of the microphones and all the electrical parameters that are required for the sound level meters. So this is just a block diagram of that system, where you can see that a speaker is there connected to the power amplifier and a signal generator, and a voltmeter is there to identify the voltage and analyze the change in the voltage while the speaker is generating the sound pressure level. And at the receiving part is the microphone, the reference microphone, which is calibrated by the primary method, and the sound level meter, which is basically calibrating, which is to be calibrated. So these all are the international standards which we follow as for which are being recommended for calibration of all these equipments, and one can have a look on these standards, and they can buy it from either BIS or from the IEC to understand what is the methodology for against these calibrations. So as I was telling you that CSIR NPL has also taken a lead role in this regard, and we have been in various committees of the Central Pollution Control Board, Central State Pollution Control Board, and we have we have been submitting the various projects in various pollution control boards for noise mapping and noise pollution prevention and control. Even we are taking the testing of the DG set rigorously also, because the government of India has in 2005 they have rigorously enacted the rules for testing of DG sets, and now a DG set cannot be sold in the market which is qualifying a criteria of 75 dB at a distance of 1 meter. So you can see in the picture that we have to take, we have to, as per ISO standard, we have to undertake the measurements of noise levels of DG sets, so that we can ascertain its compliance to the standards set up by the government of India. And for the firecrackers noise also, we are always every year we are testing the firecrackers for their compliance, because there is a rule that the firecrackers cannot be sold if it is generating a noise level of more than 125 dBA and 145 dB CP. This was just a study, if you can see this slide, by a collaborative study with NIRI Nagpur, where they have tried to develop green crackers, which are now endorsed by the Supreme Court, and we try to analyze the sound pressure level and how the sound pressure level are there within the, whether these are there within the limits, because I think the green firecrackers, they are not only less noisier, but the the air pollution levels are also created to a lesser extent as compared to the conventional crackers. So maybe now I can stop here. Maybe I request my colleague Dr. Chitra Gautam to just briefly uh, describe about the testing activities, and then maybe I can summarize with my 3-4 slides left. So I request Dr. Chitra Gautam, ma'am, are you there?
Yeah, yeah. Thank you, Dr. Naveen. Now I'm sharing my slides. Yeah, is it visible?
Yes, very well.
Yeah. Okay. Now, as Dr. Naveen already told you all the things, now I have left a very little portion. So now I'll start from the sound and noise. What is sound and what is noise? So what is we are listening is sound. Sometimes it will feel like a noise. So how will differentiate? Sometimes when we are listening some music, it will be good for me and it will uh, good for me, so I can see it is a sweet music and all, and maybe it will hurt to somebody else, so it will create a noise to other person. So it is basically the difference between the sound and the noise. So we cannot differentiate at a particular level. It depends upon person to person. So now I can say that sound. What is sound? Basically, sound are the pressure variation waves that can travel through only by the air or some medium. Actually, sound waves can travel only through the medium. Before the any if we are not providing any medium to the sound, it will not travel. So to detect the human ear, basically sound needs to travel via some medium. So this is basically some basic concept of that. And then now I'll move towards the noise induced hearing loss. What is that? So when the some sound is generated, and it will not affect our hearing, so it will not create any problem to us. If that sound creates problem to our ears, and it will be very loud, long lasting for a very small time span, then it will create uh, hearing loss, and it will also damage the structure of our inner ear. So it can cause noise induced hearing loss. So due to that noise induced hearing loss, NIOSH, National Institute for Occupational Safety and Health uh, organization from America, recommended the exposure limit 85 dBA for 8 hours to occupational noise-induced hearing loss, and they have also recommended that 3 dB exchange rate should be applied. So, because at every increase by the 3 dBA doubles the amount of the noise and half the recommended amount of the exposure time. Let's just assume that if we are listening sound of 80 dBA and it will double 80 and 80 again, then it will increase by 3 dBA. So it is basically a logarithmic addition, not a simple addition. 80 by 80 plus 80 is not 160. 80 plus 80 is 83 dBA. So it increases by 3 dBA. And OSHA basically describes some permissible exposure limits in 1971 that are criteria level is 90 dBA that time, and then the threshold level was 90 dBA in 1971, and it is moving towards till today. It is with some bit corrections. It is this way, and exchange rate that time exchange rate was 5 dBA. Now it is 3 dBA. We'll discuss later. And so we can see they have described the permissible limit is 90 dBA for 8 hours, 95 dBA for 4 hours. As the noise level increases, time level will decrease by half. So this is described by the ministry. And then we can see conservation amendment to permissible limit. So it is according to the action level, it should be 50% of the permissible exposure limit, and the criteria level as described by the OSHA is as it is 90 dBA. Threshold level decreases to 80 dBA from 90 dBA to it is now 80 dBA, but exchange rate remains 5 dBA till 1981 to 83. Then till now we can see the OSHA has designed again the limits. Then now for the 80 dBA, the exposure limit is 32 hour uh, time span, 85 dBA for 16 hours, 90 dBA, and so on. They are previously, as have already previously described. Before that, above 90 dBA, there was no exposure time limit. Now they have introduced 80 and 85 dBA for 32 hours and 16 hours. Then the threshold time value and the recommended limit for noise are recommended like criteria level is 85 dBA. From 90 dBA to 85 dBA it is shifts. Then threshold level shift from 90 dBA to 85 dBA, and now it is 80 dBA. And now we can see that the exchange rate is now 3 dBA from 5 dBA, from 5 dBA to 3 dBA. And this slide is already described by the Dr. Naveen, as he has already told that we have four categorized zones: silent zone, residential, commercial, and industrial, and described limits are there for the daytime and nighttime, which Dr. Naveen has already discussed. So I think I can skip this slide. And I'll start from the sound pressure level. So what is the sound pressure level? Sound pressure level is the logarithmic measure of the effective pressure uh, related to the reference level. And what is the reference level? Reference sound pressure level is the 20 micropascal. So we can calculate the sound pressure level from this formula, and it is measured by the dB, decibel units. And this is, I have already discussed that when we are adding the sound pressure level, it will increase by 3 dBA. It will, as I have already told now, that if we are listening sound of 80 dBA and we are just doubling the sound, so the increasing level will be 83 dBA, because it is the logarithmic addition. It is not a simple arithmetic addition. So we can see here 80 dBA plus 80 dBA is equal to 83 dBA, 100 dBA plus 100 dBA, it is 103 dBA, and so on. Then in our CSIR NPL laboratory, we are doing some testings also. Apart from the calibration, we are doing acoustical material testing, and it will basically categorize into two categories: sound absorption coefficient category and the sound transmission coefficient, sorry, class. So in the sound absorption coefficient, we are actually using the reverberation chamber. Sound absorption and sound transmission, both class, in both the methods, we are using reverberation chamber method. And the CSI NPL is having the 257 meter cube and the 271 meter cube reverberation chamber volumes, two different reverberation chambers, and I think it is the largest reverberation chamber in the India itself. And we are using and maintaining all the things according to the ISO standards and ASTM standards. And in the reverberation chamber, the reverberation chamber is basically equipped with the diffusers, then reference sound sources, then microphones, and the sound level meters we are using from the remotely access, because the sound generates in the reverberation chamber is around 110 to 120 dBA. So it is very harmful for the human ear. So we are remotely taking readings from the control room. So this is the basic diagram for the reverberation chamber. In the reverberation chamber, we are using omnidirectional sound source, which is used to generate the 110 to 120 dB of pure tone sound. And we are placing by ASTM standard. We are using some ASTM standard C 423 2017, from which we used to decide that how the material mounting method, which material mounting method we required. The material method, mounting methods are basically starts from rigid backing to 900 backing. So in that case, we generate the sound. We generate the sound source, generate the sound from the sound source, and we amplify the sound into the chamber. And this sound is falls on the sample, that the acoustical material sample. This acoustical material sample, then the sound generates in the room. It will reflect, absorbed, and transmitted by the walls which are present into the chamber, and some uh, sound is sound energy is absorbed by the acoustical material. So then we used to capture that sound energy loss in the room with the help of the microphone, and we are basically changing the positions of the microphone in the room for taking the several experiment readings, so that we can get the accurate sound absorption values in that room. And we are using the one-third octave band from 100 hertz to 4000 hertz in that case. And when we are getting the sound, and when we are getting the sound pressure level from the microphone that is fed into the sound level meter, with the help of the sound level meter, we getting the reverberation time uh, in the frequency range of 100 to 4000 hertz, 4000 hertz, and getting the absorption at each and every frequency level. So in that case, in the reverberation time, when we are calculating the sound absorption coefficient, we used to measure the reverberation time. And what is the reverberation time? Let us discuss first that in the for the reverberation time, when we used to generate the sound from the omnidirectional source, and we cut off after a certain level, we cut off that sound. Uh, then the decay of that sound till the 60 dBA, what will be the uh, uh, time to decay from cutoff to the 60 dBA? That is called the reverberation time, and it is calculated by the Sebian equation, that is 0.161 V upon A. V is the reverberation chambers volume and A is the sample area. In our case, for the sound absorption coefficient calculations, we are using basically 10 to 12 meters square sample area. So for the noise reduction coefficient, we are calculating the absorption value with the formula of 55.3 into V by 12 into 332 plus 0.60 bracket में 1 upon RT minus RTS. RT is the reverberation time of the empty room, and RTS is the reverberation time of the when the sample is placed inside the reverberation room. So from this formula, we are calculating the uh, absorption at each frequency. Then we are calculating the noise reduction coefficient by averaging the four absorption value at 250 hertz, 500 hertz, 1000 hertz, and 2000 hertz. That gives the sound absorption coefficient. Then we move towards the sound transmission class. It is also measured in the reverberation chamber, but the difference is that the sound transmission class is basically we are taking samples to see that how much sound is traveling from one room to other room or one area to other room. In that case, we are using two reverberation chambers, and one wall is common. In that case, that common wall is placed with a window, some specified window. That window is used to place the sample, which has to be tested for the sound transmission class. So in that case also, one room is called source room and other one is called the receiving room. Then the omnidirectional sound source generates the sound in the from the source room, and simultaneously we are observing the sound in the source room as well as in the receiving room. So from this, we are seeing that how much is the difference in the sound pressure level in both the rooms. So it will give us the sound transmission loss of the room. That sound transmission loss we'll getting in the range of one third octave in 100 to 4000 hertz, 4000 hertz. With the help of sound transmission loss, we are calculating the sound transmission class. That is basically showing how much sound is traveling from one room to other room. So, which we used to calculate by the ASTM E413 2016 method. In that, we used a contour plotted on this standard reference curve contour, and we usually plot our sound transmission loss curve onto that, and we are imposing at 500 hertz uh, that curve, and we are getting the sound transmission class value at contour is intercepts at 500 hertz. So this is the method to calculate the sound transmission class. Now we'll move towards the acoustical material. So in day-to-day life, we are not bothering about the acoustical material, and even we don't know in our closed premises how much the material is acoustically treated or not. But most of the time, if we are seeing that most of the material is acoustically treated, like in the auditoriums, you can see the all auditoriums are acoustically treated. Then home theaters, then PVRs, they all are acoustically treated. Music rooms are there also. So they are treated with the help of absorption properties and or sound transmission properties. So basically, we categorize these type of acoustical material into the synthetic material as well as into the green materials, or we can say the natural fiber materials, which are nowadays very popular. So first we can see the properties of the acoustical materials are they should be good in absorption and low reflection and high absorption of sound. Noise reduction and absorption should be there. And high density of the material improves the sound absorption efficiency. So we need good absorption. If we need good absorption, so we should have the material with the higher density. It suppresses the echoes, reverberation, resonance, and reflections also. Then we move towards the synthetic materials. So some of the examples I have listed here, so we can go one by one. One is the concrete blocks. They are basically building materials, lightweight materials, and in our day-to-day life, we are seeing that they are the materials, say AC block materials, hollow concrete blocks material, and aerated blocks, etc. are there. But we used to see like they are only for construction purpose, but it is not only for construction purpose, but they are also treated as acoustical material, and they are having a good sound transmission class property, and they properties depends upon the density, pore size, and the distributions of pore concrete mixtures which we are using to build the buildings. Then I move towards the clay bricks, which is commonly used to build a house, and they are the basically green building material. It lies into the synthetic material as well as into the green material, because if you mix some other synthetic material into a clay or something else, so it will behave like a synthetic material also. And if you are using only mud, so it will use as a green material. So they are basic nowadays. They are basically into the different shapes. They are used as insulating bricks. They are also used as sound insulating bricks, mud bricks, etc. And they are useful for the institutional buildings purpose, then residential building purpose, and the commercial building purpose also. They are also having a very good sound transmission class properties, and the sound transmission class varies from 30 to 40 uh, in clay bricks. Then the acoustical forms, which are basically used as soundproof material, and they are most popular to build in the gymnasium, churches, and then theaters, recording studios, etc. Because they are having very good sound absorption properties from zero point 0.9 to 1 level. They are having this kind of sound absorption, and they are very mostly available in the form of polyurethane and polystyrene. So they are having grooves. Different kinds of grooves are there. So they depends. These grooves depends that how much the sound is absorbing, and the sound absorb. This is also depends upon the sound absorption properties. You can choose according to your requirement. Then the gypsum boards, they are basic nowadays. Nowadays, gypsum boards are also very popular. They are primary building material. They are also known as the plaster boards or drywalls. People are using as a drywalls, partition walls also, as a partition wall also, and most popularly they are using in the building materials. But nowadays people due to the uh, space limitations, people are also using in the residential purpose also. and they are very high sound insulating properties, so that it is easy to use into the residential houses also. Then the metal, which is already we have already known that the doors, mostly doors are available in that category. Then glass windows frames are also there, and then louvers, noise barriers. They all different kind of things are made up from the material. The material can be steel, aluminium, iron, glass, or and so on. They are basically used for sound dampening with the sound dampening material. So uh, these kind of material are having also having the sound transmission loss properties with that. But when you are using sound dampening material like rock wool, glass wool, etc., with this, then they are more effective, and they used to stop sound traveling from one room to other room or one place to other place. So they are best fitted for making doors, louvers, etc. They are basically high sound and insulating material, as I have already discussed. Now the glass. Dr. Naveen have also discussed about the double glazing. What is double glazing? Double glazing is the two different glasses, which is basically infilled with the vacuum, basically. Because as I have already told you, na, the sound needs medium to travel. If we are not providing medium to travel the sound, so sound will break. So double glazing, triple glazing are different kind of glasses materials are there. So they basically reduce sound from one place to other place. So the best example we can see the commercial buildings, then the official buildings, corporate offices. We can see when we are in the corporate offices, we cannot listen sound from outside, and the whole building is covered with the glass. This just because of that glass properties, that maybe double glazing, triple glazing, or treated with the sound acoustical material, that provide you the sound insulating properties, and it will break sound from outside to inside. So uh, this kind of sound glasses are basically used as a soundproofing glasses. Then we move towards the polycarbonate sheets, which in day-to-day life we have already seen at the metro stations or footpaths, pavements, etc. They are basically looks aesthetically beautiful and used as a noise barrier. Yeah, if you have ever seen near the metro station or at the metro station as well as the highways, etc. But from our opinion, we have tested lots of polycarbonate sheets. They are used as a noise barrier, but they don't have this that much of capability to reduce sound. But so alternate of the polycarbonate sheet, we can use some other methods to use as a noise barrier. It can be a green method, like we can do the plantation, or we can use the concrete and some other materials also. Now we move towards the green material. So in the green material, most of the green materials used by the natural waste. So first I will start from the sugarcane bagasse. Sugarcane bagasse is a natural waste and the green material. It is used for the building, automobile and noise instrumentation to reduce the noise, and it is used also for the partition purpose to reduce the sound. Then we can go towards the woven fabric. Woven fabrics we have already seen into our auditorium, etc., that they are using the curtains, but we are not aware that they are acoustically treated. But they are acoustically treated. When we are designing some auditorium or any other theater kind of places, so we have to maintain the acoustical properties. Sorry. So we are looking into that the curtains or blinds should be with the acoustically treated. So they are giving the best performance at the 1000 hertz. And then we'll move uh, towards the jute. Jute is very popular, and I think from last 50, 60 years we are using the jute. The jute fiber extracts are very eco-friendly and biodegradable and used in the building, partitioning, flooring, roofing, car door panels, etc. And they are also used by mixing the cement or concrete or clay, etc. to make the noise barrier designing, as well as for the building design for the civil construction use, so that noise will travel less from one medium to other medium. Then this is a rock wool. Rock wool is basically a silica fiber or rock fiber. It is highly sound absorbing material. It's 90% to 90% to one. They are giving the value of the sound absorption, and they are basically used for the roof, flooring, ceiling insulation, etc. Then mineral wool, it is basically rock wool or stone wool, we can say. It is a safe mineral wool as compared to the rock wool. And it is used to, as I have already discussed, that if you are using metal, then if you want to increase the sound insulation properties of the door, so you can use that mineral wool or rock wool or glass wool in between the two metal sheets, and you can increase the sound transmission loss properties uh, of that material. So they are actually affordable and fire resistant and moisture resistant also. Then the fiberglass, or we can say glassine material, they are also uh, made up with the glass fibers using binders, and they are also used as the infilled material, but they are hazardous to health. So if we want to use that material, so we have to be extra cautious to by using that material. So we have to take extra protection by covering our hands and mouth, etc. So then wood, wood is commonly used as our doors. Then uh, houses are also made in the several places from the wood. So wood is also plays a very important role for the sound absorption and sound transmission properties. So basically, wood is all used in the form of oak, acoustical plywood, and medium density fiber boards, plywoods, etc. Then the most effective acoustically woods are pine woods, oak woods, edge, and sapling, etc. These type of woods used as a acoustic panels, ceiling panels, baffles, partition panels, wooden doors and windows, and used for the ceiling walls, roof, auditorium, as we have already discussed these things. Then a Kanoff fiber. Kanoff fiber is basically a vegetal fiber. It belongs to the cotton or okra kind of uh, hibiscus beans, and these type of Kanoff fibers are basically used as a ceiling panels, and they are basically reduce the sound travel from one place to other, as well as they are very good fire resistant and moisture resistant properties. Apart from these kind of material, there are also several kind of materials available in the market that are cellulose fiber, natural fiber, cotton, flax fibers, pulp, etc. So from the natural and synthetic fiber point of view, I move towards the noise control method. So I will show one or two noise control methods here. So here are noise barrier. Dr. Naveen already told how we can design the noise barrier. So I'll just give you a glimpse that where we can use a noise barrier. So, as I have already told you, the polycarbonate sheets widely used as a noise barrier, but they are not good sound transmission. Uh, they are not good in the sound transmission class, and they are having around 80 to 20 value of the sound transmission class. So we can use different other different kind of material to use as a noise barrier that can they can be bricks, concrete, or mud or steel, plastic, insulating wools, etc. by filling some insulating material also. But they can be cost effective as well as human as well as in environmental friendly. So we have to take care about all these aspects also. Then sound absorbers. So sound absorbers, as we know, they if the acoustical material absorbs sound in better way, that will reduce the sound. So the sound absorbers also plays as a noise control method. And one example is the sound raffles, which we can see, acoustical raffles, sorry, which we can see in the photographs, that they are basically a acoustical baffles and used as a sound absorber at several places. You can use it. They are aesthetically beautiful as well as they are used as a sound absorbers. They are basically used in the residential, commercial building, offices, theaters, and recording room, etc. Then I have already told that vegetation or plantation can reduce the noise level, and it is the best way to control the noise without any much effort. So we have to do efforts uh, only to do the plantation. It will reduce the traffic noise, as we have already gone through the studies, so we can see they need very low maintenance, and they are very good in the sound absorption characteristics. So nowadays we can easily see that near the metro stations we can see the vertical gardening is there. Most of the people are saying that the people are doing this kind of vertical gardening just because of reducing the air pollution or showing the city beautiful and all. But it is also having a different aspect that they have used to reduce the sound also. So if we'll see in our nearby places, we can find lots of things which we are having into our near premises, which we can control the noise. But we have to think about it. So there are some acoustical material testing services we are counting in CSIR NPL premises: sound absorption coefficient, sound transmission, then noise and vibration measurement, pre-field measurements of DG sets, and then firecracker measurements is also there, lower testing, and then noise barrier testing is also there. Apart from that, we are doing the sound absorption testing of the chair, furniture, hanging baffles, etc. So this kind of around 15 type of testing we are doing in CSIR NPL campus. So this is from my side. Now uh, I would like to call Dr. Naveen. Please take up.
Yeah, thank you, Dr. Chitra. Am I audible?
Yeah,
Yeah, so already I think we have the time has come to stop, but just to summarize that, as Dr. Chitra has already discussed, that these types of testing activities are being undertaken. I think my screen is visible.
no,
Not yet.
Is it visible now?
no.
Just a minute.
Now you can.
Is it visible now?
Yeah, now it's okay.
Yeah. So I will just try to summarize that what Dr. Chitra has discussed. So you can appreciate that not only acoustic metrology, but we are undertaking a lot of testing activities for developing various products which are helpful for noise prevention and control. And in fact, most of the building manufacturers in the country, the leading building manufacturers, they are coming to NPL and they are getting their products certified and tested by NPL for the sound insulation and absorption properties. And these are used all over the metro stations, airports, auditoriums, etc. So you name any building manufacturers, so they are actually getting their services from NPL itself. And apart from that, we are basically we are focused in doing research activities also towards developing better acoustical materials which are providing higher sound insulation. So some of our PhD students, they are really working on that, and we are publishing papers in the reputed international journals also. So you can see that all these things contribute towards the noise pollution, because as I was telling, that source is control is very good, but when you are not able to control the source, then you need to take a measure at the receiver. So if we can control our noise, if we can make our homes strengthen, if we can strengthen our homes basically in terms of sound insulation, so maybe the external noise will not be influencing us to a greater extent. So all these types of research studies are being undertaken by NPL, apart from providing routine testing activities. And nowadays, as Dr. Chitra Gautam told, that we have a drywall technology that is coming into picture, which is better than the conventional brick wall structures. Gypsum panels and all these things are being manufactured by various manufacturers in India, and these testings are being provided by NPL. So with that, the product is improved as and when they are getting their materials tested by NPL. So they go on improving the performance of the materials by doing more and more with new designs. So this is just an example of the window glazings from a leading manufacturer, Fenestra Building Systems, where we have tried to develop some of the good window glazings which can provide a better sound insulation in our homes. So just to summarize now, the whole since I think last 2 hours we'll be discussing. We had discussed about the acoustic metrology, the role of acoustical materials, the testing activities provided by the NPL. So if I could summarize it, see, apart from that, the strengthening of the traceability chain, the strengthening of the national acoustical measurement standards in India. Apart from that, we need to undertake some of the policy framework and challenges are there, in fact, in that regard, where I think the legal metrology can play a very vital role. Strengthening the acoustic standards and establishment of the facility for calibration of noise monitoring terminals, I think this is the key point where legal metrology can come into picture. They can help us a lot, and they can really take this initiative, because as you can see that since government is trying to make and more noise monitoring terminals in the each and every corner of the cities, so they need to be calibrated, because with due course of time there is a drift in the sensitivity of the microphones when these are exposed to the harsh noisy harsh weather conditions in Indian scenario. So organizing societal training workshops etc for the administrative bodies, which NPL is already undertaking. Focus on developing cost effective solutions, which we are already working on. And as so in the morning Vineet sir discussed that we need to strengthen our guidelines and we need to provide a better acoustical services. So we are trying to develop some new products related to, like for loudspeakers, public address systems. We are trying to develop noise limiters in collaboration with a company. Noise labeling of appliances, as I told. The reformulation of the ambient noise standards, I think, should be also there. Modified silencers, screen crackers, and use of sound limiters. So apart from that, the standards and the legal guidelines have to be also focused. So developing noise standard for construction site, this is already underway, and in collaboration with Delhi Pollution Control Committee, we are trying to develop the construction noise guidelines, zero tolerance for unnecessary honking. That should be, I think, the first and foremost criteria. Strengthening the National Building Code of India to include the building codes for acoustic comfort and noise control. So this is also an initiative that we are taking in collaboration with the Bureau of Indian Standard, and recently we organized a workshop in that, so that we can reformulate our national building code and we can make at par with the other countries, so that we can provide the we can take initiatives towards noise pollution control. Enhance prosecutions, fines, and wide publicity to campaigns, enforcement of rules. I think that those are beyond NPL but prerogative, but I think the legal bodies and the police, state administration can take a key role in this regard. So overall, I think if we can implement these types of measures, So we'll definitely end up with reducing the noise pollution in our country. And just to summarize that this type of workshops we are organizing, like in August 22nd and 23rd, we organized an international workshop on building acoustics and noise control. So these all initiatives are being taken by NPL to basically inculcate awareness, to educate the students, researchers, and to basically uh, train our industries and manpower so that they can develop better products for noise pollution control in India. And I'll be glad if all those who are attending, if they can just read this book. This has been recently published by Springer. The book covers 10 chapters, and it has been written by me on basically on environmental noise control, the Indian perspectives in an international context. So I basically tried to focus on each and every aspect of the noise pollution in India and how these can be resolved. So I think for the students, this will be a good thing if they can just read it from or they can download it from the Amazon. And these are some of the publications that we, as I told, that we are also trying to do some high-end R&D so that we can disseminate to the information to the general public also, and to the researchers also. So we are trying to publish some papers also in that regard. So all the research scholars who are attending this program, they can go through these papers and they can try to and they are most welcome to collaborate. And if they want to learn anything, or if they are interested in any training programs, we shall be glad to organize such a training program. So I again end my presentation here, and I thank the organizers, especially Dr. Ashutosh Agarwal ji, for giving us an opportunity to discuss about the acoustic metrology and noise pollution control in India. I hope we have, to some extent, uh, we have covered the objectives of this workshop, and maybe in future we'll like to associate it with legal metrology department on organizing such training programs and workshops to inculcate awareness amongst the industries and students. So thank you once again, and I look forward for any questions or any queries in this regard.
Thank you. Thank you very much, sir, for your kind and brief presentation, Dr. Garg, Dr. Chitra Gautam. Thank you very much. You have explained the topic very well. Really, on behalf of all the participants, on behalf of Legal Metrology, I would like to thank both of you. Sir, we would like to have one workshop on this National Building Code as soon as possible, within a month or so, whenever you are free, one Saturday for 2 hours. If you can kindly do this, because it is also a very important topic, National Building Code, how we can do and what are the requirements. We would like to have this subject also whenever you are free and having the time. And with this, thank you, sir. Thank you very much. With this, I would like to thank our Vineet Mathur sir, Joint Secretary Sahab, Dikshit Sahab, and all the participants who have participated in this workshop with my NIC team, Mr. Santosh, who is organizing all this. Thank you all. Thank you very much. Thank you.